Okay, let's use the sum and difference formulas for tangent. So in this case, the first thing we want to do is we want to find the exact value for a tangent of pi over 6 plus pi over 4. So we have a sum and addition going on inside of our tangent function. So we're going to use the sum formula listed up above there with alphas and betas. And as we get going on this, I always like to just label things that we're going to use pi over 6 wherever we see an alpha in the formula, and we're going to use pi over 4 wherever we see a beta in the formula. So we can rewrite this pretty easily as tangent of alpha, but pi over 6 goes in that spot, plus tangent of beta, but pi over 4 is going to go get substituted in that place, all over 1 minus the tangent of alpha, but again, we're doing pi over 6 times the tangent of beta, which is pi over 4 in our case. All right, so now that we've filled into the formula, now we need to evaluate stuff along the way. So we can evaluate pi over 6 and pi over 4 are some pretty nice values that show up a whole lot. So we can say, well, pi over 6, when we plug it into tangent, is going to give us the square root of 3 over 3, plus the tangent of pi over 4. We can evaluate that, and we're going to get a 1 over 1 minus, again, tangent of pi over 6. We're going to replace that with square root of 3 over 3 multiplied by tangent of pi over 4, which we can replace with a 1. All right, so we're in a pretty good spot here, but we can clean this up and make this look a little bit nicer. Now, obviously, we could drop the multiplying by 1 here at the end, but we've got bigger things going on that we have fractions inside of fractions. So what I would suggest to start cleaning this up is if I want to eliminate these little fractions within the big fraction, these little fractions have some dividing by 3 going on for both of them. So I want to counteract this dividing by 3 in the numerator and the dividing by 3 in the denominator. So what I'm going to do is I'm going to propose that we multiply by 3. We have to multiply the entire big numerator and the entire big denominator by 3. By multiplying by 3 over 3, that's equivalent to multiplying by 1, so it doesn't really change the overall value, it just makes it look different. All right, from there, I'm going to go ahead and distribute this 3 from outside that we just put there. It's going to get multiplied by each one of these terms in the numerator and by each one of these terms in the denominator. So be a little bit careful, take your time as you're doing this. As we take the 3 from the outside, we multiply by this fraction in the numerator. Multiplying by 3 and dividing by 3 are going to counteract each other. We're going to be left with the square root of 3. But then we also have to remember this was 3 times 1 up in the numerator, so it's the square root of 3 plus 3 over this 3 gets distributed. 3 times 1 makes 3 minus 3 times this fraction. The 3's get to cancel out, but we're still going to be left with that square root of 3. Now there's a chance this is a good enough answer. However, we do still have a square root in our denominator. So we may want to go a step or two further to rationalize our denominator, to get rid of any radicals from our denominator. So to do that, what we want to do is we would want to multiply by the conjugate of our denominator. So the conjugate means the exact same two terms here from our denominator, the 3 and the square root of 3, except you would want to change the sign in between them. So the conjugate for 3 minus the square root of 3 is 3 plus the square root of 3. And I want to multiply both numerator and denominator by that conjugate. So 3 plus the square root of 3. All right, from here, it does take a little bit of effort to go first, outer, inner, last, and just take our time and distribute. So in the numerator, I'm going to go square root of 3 times 3 is 3 square root of 3. That's my first. My outer, square root of 3 times square root of 3 is going to be plus 3. Outer. And then inner, 3 times 3 makes 9. And last, we have 3 times square root of 3. So plus 3 square root of 3. Something very similar going on in our denominator. I'm going to go kind of quickly on this, but we go first, outer, inner, last. To get, what we end up with in the denominator. All right, so as far as simplifying down goes, we can do a little bit of simplifying when we have like terms or like radicals. Sometimes we refer to these as. You can go ahead and say, well, 3 plus 9, those are like terms. We can combine those together. That's going to make 12. You can also say we have 3 square root of 3's and we add 3 more square root of 3's. That makes positive 6 square root of 3's. In our denominator, we can say, well, we have 9 minus 3 is going to leave us with 6 down here. And then these middle two terms here, these are like radicals, right? So you have positive 3 square root of 3, and you're subtracting away 3 square root of 3's. So those can cancel each other out or make 0 square root of 3's. All right, the very last thing I may go ahead and do on this is split this apart and say, well, 12 divided by 6 plus 6 square root of 3 divided by 6. Take that denominator and put a copy with each term in our numerator to split this apart. Then we can reduce down just one step further. 12 divided by 6 makes 2. And then our 6 over 6 makes a 1. We're going to be left with the square root of 3 for the second term. So I hope this helps out as you're working on filling into the sum and difference formula for tangent. Fill in everything, just keep organized at the beginning, and then substitute in using, if you can evaluate tangent of pi over 6, evaluate it, get the appropriate ratios coming out, and then simplify where appropriate from there. So I hope this helps out. Good luck.